In this video, we are going to solve the Leetcode problem, daily temperatures. We are going to solve it in two different methods. First, we are going to solve it in brute force without any extra logic, without a lot of thinking. And then we are going to optimize it so that you are able to solve it in the most optimal way. And we are going to learn about something called as monotonic stack when we actually try to solve it in optimal way. Now let us go through the problem. So we are given an integer, an array of integers, temperatures as an input. It represents the daily temperatures. What we have to return in this problem is an array in which, let us call the output array as answer, in which every data answer of I is the number of days you will have to wait for the ith day to get a warmer temperature. But if there is no future day for which this is not possible, or for which this is not available, then we have to give the answer as 0. Basically in this problem we are given a list, right, or an array, and that is called temperatures. Every data is representing the temperature of the particular day. This you can call as day number 1, day number 2, 3, 4, 5, 6, 7, 8, right? So you are given daily temperatures of 8 days, or you might be given daily temperatures of 4 days. It depends upon the constraint, right? The constraint says that we could have 10 to power 5, 10 to power 5 number of days, or you can say the length of our input can be 10 to power 5, and the temperature will be within the range of 30 to 100. So we are given temperatures, right? Now we have to return an output as a list which will have the same length as we have for the temperatures array or the list. The thing is, for every data, for 73, for 74, that is for every day's temperature, you will have to return the output as the number of days you will have to wait to get a warmer temperature. You could understand from here. What I can understand from here is every answer of I is the number of days we have to wait for the next ith day to get a warmer temperature. That is, if you talk about 73, the output here is 1. It means after just one day you will get a warm temperature. Today it's 73 degree, next it is 74 degree. It is warmer, right? When you say warm temperature, it means the temperature will increase. So from 73 it just took one day to get a warm temperature, 74, so the output is 1. For 74 it took one day, which is 75, so the output is 1. For 75 you will have to wait for 1 day, then 2 days, then 3 days, then 4 days to get a warm temperature, to get any temperature which is more than 75, right? We have 71, 69, 72. These are temperatures which are not warm compared to 75 degree, right? And that is why you will see the output here is 4 for 75. For 71 it is 1 and 2. 2 days you will have to wait to get a warm temperature, and that is why the output is 2. For 69 it is 72 just in one day. For 72 it is 76 just in one day. For 76 the remaining temperature you will see is just 73. You are not going to get a warm temperature. So if there is no future day for which this is possible, then we are going to keep the answer as 0 for that particular data. For 73 it is the last data, so we could simply say it is 0. We are not having any future days, right? Now to solve it in a brute force way, what we could actually do is, let's create an array, and you will see that the brute force solution is very easy to understand. What we can actually do is, we could just pick a particular number, let us say 73, and then loop through the other data to get a warm temperature. If we are able to get a warm temperature, then we would just assign that number, that hey, this is the number of days it took to get a warmer temperature. If we are not able to get it, then simply we could say it is 0. So what we could say is result is equal to, let us say it is 0 multiplied by length of temperatures, right? Now this will create an initial array. I would say 0 comma 0 comma 0 comma 0 comma 0. The number of times you will have 0 is the length of the temperature, right? So you will get an array like this. So this is your initial answer, that all are 0 as of now. Now let's run a simple loop. We could say for I in the range of length of temperatures, right? Let's go through each of the temperature, and what we could actually do is, we could run another loop. We could say for j in range of from I plus 1 to length of temperatures. And why I am doing this, let me tell you. The thing is, when I am pointing to, let us say 75, so I want to run through the other data, the future data in my loop, right? The future data in my array, so that I could see that when I am getting a warm temperature, right? All right. Now what I could do simply is, I could just have a simple check that if the temperatures array, if the temperatures of, I would say j, because j is the future day, right? J index is representing the future day. So if the temperatures of j is more than the temperatures of I, then we have got the, I would say we have got a warmer temperature. So I could simply say result of I, because we are running the loop for our ith data. So we could say result of I in this particular array. We are going to update our result. It will be j minus I. Basically j minus I is representing the number of days, the difference in the number of days, right? For example, if we are pointing at this particular data which is at index number 1, or let us say 75 which is at index number 2, then the answer would be, for 75 it would be the 76 which is going to have a warmer temperature. So you would see that this is at index number 2, this is 3, then 4, then 5, then 6. Basically index number 6 minus index number 2 is going to tell me how many days it took, or how many indexes it took to reach to 76, right? That's basically j minus I. That's the difference which is telling me how many days will it take for a particular day to reach a warmer temperature, or to get a warm temperature. So now once we are done with this, we don't need to actually worry about the zeroth condition that whenever we don't get a future day which has a warmer temperature, we don't need to worry about that because our data initially is having all zeros. So this will only get updated when we actually get a warmer temperature, right? And now we could simply say return result. Now if you run this, you will see that the sample test cases given here will be passed. Okay, so we are getting a wrong answer, and that is because the output here is 6544322. Okay, so we are getting the wrong output, and the reason is we are saying G minus I. Alright, I think we are doing something wrong. Let me just check this. Alright, what we actually need to do is, just when we update our answer, we have got the warm temperature, we could simply say break, right? We don't need to run this loop continuously, and the reason is for 73, 74 is warm, 75 is also warm, 71, not 71, but 76 is also warm, right? So if you don't break it, it will going to update to the last data. So I think this should do it. Let's run this and let's wait for the solution. Alright, so sample test cases you can see are passed. If you submit this, then I think this might pass all the test cases as well. I don't think so, because I see the constraints are 10 to the power 5, right? The array length is 10 to the power 5. So we are going to get time limit. Yes, time limit exceeded error, which is fine. So this solution is fine, but it is not the optimal one. So let me do one thing. Let me actually get rid of this solution. Let me delete it out and let's restart solving this. But this time we are going to be a little bit smart. Let's do one thing. Let's actually assign a variable n, which is going to be the length of temperatures, right? And then replace this result with result equal to an array of 0 multiplied by n. Now up to this point we have not done anything, but what I would actually do is I would say that, see, try to understand about this. I would say let's run the loop from the opposite side, and I will tell you why. See, the thing is, we don't know the answer for any of the data, right? No, we actually know the answer for one of the data in this temperatures array before we actually start solving it. That's basically the last data. For the last data, it is always going to be 0, right? The reason is, after this last data, we do not have any future day. We definitely will never get a warm temperature. So for this, we already know the answer, right? Now we can just run a loop from in the backward direction, an opposite loop from 73, then 76, then 72, then 69. Like this, we can run the loop. And how is this going to help us? We already know the answer for the first data. Now we can start from here. And from here, we will start building our answer in an optimal way. And I will tell you how. Let's assign a stack. Let's say we have a st which is equal to a list. This will behave like a stack. We are going to use it like a stack, right? Now let me run a loop in the opposite direction. I will tell you why, and I will tell you how you can actually think about this. If you don't know the solution, how can you actually think about this? But you should know about something called as monotonic stack. So I think if you don't know about this right now, let me try to explain you by solving it, not just by theoretical way. If once I start solving it, then you will understand it more. So let's run a simple loop for I in the range of n minus 1. Then we can say it is minus 1, and then we can say it is minus 1. Basically, this is our starting data, which is pointing to the last index. Then we are going to run the loop till we reach the 0th index. And this is just the step that we are taking the step in the opposite direction. See, the thing is, guys, why are we using a stack? Let me tell you. We have the last data is 73, right? For 73, we are definitely going to get the answer as 0, right? So let me put it 73, which is at index number 7. For this, the answer is going to be 0, right? Now let's talk about 76. For 76, if you notice, for 76, what 76 needs? It needs a temperature which is more than 76, right? As of now, if you see, we do not have a temperature in the future which is more than 76. So if we do not have it, then 76, which is at index number 6, will have an answer as 0. But when we talk about 72, which is our next data, then for 72, the index is 5. The answer is going to be 1. Now, how are you going to get the answer? See, the thing is, what we can do, once we process our data as 73, what we could actually do is we could say that the last data which we have seen is at index number 7. Alright, we have seen a data at index number 7. Let's put it in the stack. So our stack has a data 7, which is actually representing the index of our data, because ultimately we are going to calculate the number of days through the indexes, right? Alright, so once we process 73, it is going to definitely have 0, the answer as 0. But now we have seen a data which is at index number 7, the data is 73. Now what about 76? The moment I see 76, I will check my stack. I will ask my stack that, hey stack, tell me what are the different data you have. So stack will say, I have the index number 7. For 76, I will check the index number 7. Is the index number 7 having a warmer temperature? No, it is not having a warm temperature, right? It is having a cool temperature. 73 is less than 76, right? So it is not having a warm temperature. So what I can actually do is, I don't need 73 now. The reason is 76 will get an answer from 73. It didn't got an answer because 73 is a warm temperature. Now 73 is of no use. No other data in my array is going to use 73 to know that this is a warm temperature, right? Because 76 is more than 73, right? If there is any data in the previous days which is going to get a warm temperature from 73 or 76, it is definitely going to be 76, right? For example, for 71, for 71, 76 is the warmer temperature, because we got a data which is more than the previous data we have seen. Try to understand from this perspective. We have seen a data at index number 7 as 73. Now, can 73 be an answer? Can 73 be a warm temperature for some other data? Yes, it can be. But the moment I see 76, I am sure that since 76 is more than 73, I am sure that there is no future use of 73 because no other data in my array is going to use 73 as its warmer temperature. It is going to be 76 at least for now, right? Maybe in future we see a bigger data and that data will become our warmer temperature for other data. No other data is going to use 73. So what we can basically do is the moment I see 76, I'm going to remove this 7, the index number 7 from my stack. So what we could actually do is we could actually have a condition, and that condition will be while we have something in the stack, the temperatures from the temperatures array, the temperatures of I, if the temperatures of I more than temperatures from the temperatures array, temperatures of st of -1. Now what this condition is checking that while we have something in the stack, initially we are not going to have something in the stack, and that is why this condition will never reach, right? This condition will be false here only. Later on we are going to push some data, but initially when we see for 73 we are not going to have something anything in the stack. So simply what we could do is we could say while we have something in the stack and the temperatures of I, my current temperature, for example 76, let us say we push 73 in the stack as index number 7, and next we see 76. So this condition will be true, right? We have something in the stack, and the temperature in the stack, the last temperature which you have stored in the stack, that particular temperature is actually less than the current temperature. If that is less than or even equal to, for example, if this is 73 and this is 73, right? So this 73 will be used, right, for other dates. If 73 is the warmer temperature for other dates, so this 73 will be used instead of this one. So anytime my current temperature, if that is, I would say more than or equal to, this will be more than equal to that last temperature which we have stored in the stack. So we could simply say st.pop, take it out from the stack. We don't need it. Let's remove it from the stack. After we are done with this, let's try to understand about this. After we are done with this, and if we don't have anything in the stack, let us say if not st, if we do not have anything in the stack, we could simply say result of I will remain as 0, right? Or better, what I can say is I can just get rid of this. But let's just explain you the condition. Why are we using this condition? Try to understand it from 76 perspective. For 76, it sees that the data is 7, but that's the index, but the data at this particular index is less. It is not warm. So at this moment we are going to remove it from the stack. The stack is going to be empty when we are at 76, and since the stack is empty, the stack is going to tell me a warm temperature. So the stack is empty, so for this data for 76 we will have no temperatures which are warm in the future. So we could simply say it will remain as 0. So we could actually get rid of this condition because it is already 0. So we don't need to process this condition. But what we actually need to do is, if there is something in the stack, let's try to understand it from 72 perspective, the temperature 72 which is at index number 5. After we process 76, we are going to push the index number 6 in the stack, and we are going to say, hey, once we enter in this in the loop, we are going to say, hey, the last data which we have seen is 6 at index number 6. This condition is false, right? Although we have something in the stack, the current temperature which is 72 is not more than or equal to the last data which we have seen in the stack. It means if it is not more than the last data which we have seen in the stack, then we have a warmer temperature in the future, right? Once we have something called as warmer temperature in the future, we are definitely going to get an answer, and we are going to have something in the stack. If we have something in the stack, we could simply say that the last data which is there in the stack, st of -1 minus I, that is going to be the number of days we are going to wait for a warmer temperature. Basically this is your j now. When we are trying it in the brute force way, we are running this loop to see all the future temperatures, but now this is our j. This is telling me that this is a future day for which there is a warmer temperature, and since it is the next future day with a warm temperature, this is my current index, this is the later index, this is j as compared to the brute force solution. So j minus I will be the number of days you will have to wait to get a warmer temperature for the ith day, right? Now once we are done with this condition, we could simply add our current data in the stack. We could say st.append I, because we have to add the data in the stack as well, right? So now what will happen, we are not removing anything from the stack, but we are saying we have 6 and then we have 5 in the stack. Now what will happen, once we reach for 69, right? Now try to understand from 69's perspective. For 69 the index is 4, the answer, we do not know the answer, it is going to be 1, but we do not know it. Now let's try to understand it from the stack perspective. In the stack, the last data which we inserted is 5. At index number 5 the temperature is warmer. Then what will happen, for index number 4 which is 69, this last data is nothing but 5, the current index is 4, so 5 minus 4 will be 1. We are going to push the last data minus I as the answer for result of I here is 4, this will be 1, so for 69 the answer will be 1, right? Now once we know the answer is 1, we are going to push 4 in the stack as well, so we are going to say 6 5 4. Now once we see 71, now this is going to be interesting guys. For 71 the index is 3, we don't know the answer. Now it will say, hey, what's the last data? The last data is 4, right? Now since the last data here is 4, what you will notice here is the last data is having a temperature which is less than the current data. So what will happen, this condition will be true. If this condition is true, it is going to pop out the last data. It is going to say let's remove 4. What about 5? For 5 also, is this the same case? At index number 5 it is 72, at current index which is 3 it is 71. No, the last data which we have seen as of now is more temperature. The temperature is more, it is warmer, it is not less. So here we are not going to pop. Now we are going to come to the next condition. If there is something in the stack, yes, there is 6 and 5 in the stack. The last data is 5. 5 minus the current index 3 will be 2, right? So for this the answer will be 2. And now we are going to push the current index 3 in our stack. So 6, 5, 3. So this is how we are building the answer. You will say 0, 0, 1, 1, 2. You can see 0, 0, 1, 1, 2. We are building the answer from the opposite side. Now one more thing which you will have to notice is there is something called as monotonic stock. That is what we are using here. Monotonic stock is either, not stock, sorry guys, it is stack, monotonic stack. So when we say monotonic stack, it means the stack is either going to be increasing or decreasing. The stack will not have increasing, decreasing data. For example, the stack will have data like 1, 2, 3 or 3, 2, 1, but it is not going to be 1, 3, then 2, then 4, then 5, then let's say -1, then 8, 7. No, this is going to be either increasing or decreasing. Here we are using a increasing monotonic stack because at index number 6 we have 76, right? Try to understand from the data, not from the indexes perspective. Try to understand from the data. At index 6 we have 76, then at index 5 we have 72, then at index 3 we have 71. So actually it is a decreasing, not increasing but decreasing monotonic stack, but it is a monotonic stack. Earlier before we see 71 it was 69, right? Now we are not pushing 71 because now this is not monotonic. We are actually removing the 69 from here. We are removing the index number 4 from here, and then we are pushing the 71, the index number 3, right? So this is the complete logic to solve it in an optimal way. Here we are not running the loop like this while condition is not going to process all the data. So this is not going to be a O of n square time complexity solution, which was in the case of brute force. Here we are just going to run to see the next data, which is a warmer temperature data. So this is actually a O of n solution because this loop is going to run less times as compared to this particular loop which we are running in the brute force solution. So I would say we have solved this. Let me get rid of these things and let's try to submit this. Let's try to see if we are able to solve it or not. So we can say return result, submit this, and this should pass all the test cases, guys. So yes, you can see that runtime is good, the memory used is good as well. So we have solved this problem. And guys, I think that's it for this video. And I know this video was big enough to explain you the brute force and optimal both. The video size was big, but my main motive was to explain you everything related to the problem. If you see the topics of this problem, it is monotonic stack. This is a very important concept in DSA. It's not a simple stack, it's a customized stack which you keep in either in increasing order or decreasing order. So I think we have solved this problem, and this introduces you to something called as monotonic stack. And if this video has helped you to understand about this problem and the solution approach and the thinking in depth, then make sure that you hit that like button. But if this video has not helped you a lot, or you think that something could be improved, then make sure that you put it in the comment box, because I want to improve for you guys so that next time you get a better video, better solution approach from my side. So again guys, that's it for this video. I will see you guys in the next video. And also, if you are not subscribed to my channel as of now, then make sure that you subscribe it. I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.